For our remaining couple of sections, we're going to discuss the law of sines and the law of cosines. So let's take a look at how we would derive the law of sines. The figure to the left shows an angle alpha in standard position, an angle beta whose vertex is B on the x-axis, or made with the x-axis, and then an angle gamma whose vertex is C. It's the upper angle of the triangle. Okay, so using right triangle trig, we can notice that basically the sine of beta is h over a, and we can also notice that the sine of alpha in standard position is h over b. Okay, so again, notice what I'm looking at here. Here's the right triangle with beta. And then we're using the reference angle approach with alpha and our XYR standard position. Okay, so now this leads me to saying that A times the sine of beta is H, and B times the sine of alpha is H, and A sine of beta equals B sine of alpha, equivalent, making the h's equivalent. So that would lead us to making the statement algebraically that sine of beta divided by b is the same as sine of alpha divided by a. Now, if you were to also take this guy and redo the triangle so C is here, and gamma is in the place of beta, and beta is in the place of gamma, then you would get a similar result that would say basically the sine of gamma over C is the sine of alpha over A, and therefore we have this conclusion. Now, it's not without its issues. There's times when this works really well. There are times when this gives you what is called an ambiguous case when you're trying to find an angle. And I will demonstrate that through examples as we go along.